For more than a century, Germany has stood at the center of neuroscience, from the invention of the electroencephalogram by Hans Berger to today's AI-powered MRI systems developed by Siemens Healthineers. Germany has repeatedly changed the way doctors look inside the human brain. Now, a new generation of technologies is transforming neurological imaging again. Inside laboratories in Berlin, Munich, and Frankfurt, researchers are building systems capable of mapping brain activity in extraordinary detail. Artificial intelligence is identifying strokes within seconds. Ultra-high-field MRI scanners are revealing structures once invisible to neurologists. And experimental imaging technologies may soon allow doctors to detect diseases like Alzheimer's years before the symptoms appear. This is the new era of brain scanning in Germany, and it may fundamentally change neurology. The story begins with one of the most important inventions in medical history. In 1924, German psychiatrist Hans Berger successfully recorded electrical activity from the human brain for the first time. Working in Jena, Berger developed the world's first electroencephalogram, or EEG. At the time, this idea sounded almost impossible. The brain was considered inaccessible. Neurologists had no way of observing electrical activity from a living patient. But Berger believed that the brain produces measurable electrical waves, and eventually he proved it. Today, the EEG remains one of the most widely used electrical devices in the world. Modern epilepsy monitoring units, sleep laboratories, and intensive care units still rely deeply on the technology that was produced in Germany over a century ago. But EEG was only the beginning. Over the following decades, Germany became deeply connected to the development of medical imaging itself. When MRI technology emerged in the late 20th century, German engineering companies quickly became key players. One company would eventually go on to become very influential: Siemens Healthineers. Today, Siemens scanners are used in hospitals across the world, but in Germany itself, Siemens has developed some of the most advanced neurological imaging systems ever built. One of the clearest examples can be found in ultra-high-field MRI. Most hospitals today use MRI systems that operate at 1.5 or 3 Tesla. Tesla refers to the strength of the magnetic field. Higher magnetic strength usually allows for higher resolution and greater detail in the images of extremely small brain structures. But in Germany, researchers have moved far beyond conventional systems. At institutions such as the Max Planck Institute in Leipzig and other research centers in Berlin, scientists are experimenting with 7 Tesla MRI scanners, capable of reaching astonishing levels of detail. These systems can visualize layers of brain tissue with extraordinary clarity, tiny vascular abnormalities, microscopic lesions, and subtle neurodegenerative changes. Structures that remain invisible on traditional scanners can be detected using ultra-high-field imaging. For a neurologist studying Alzheimer's disease, Parkinson's disease, and epilepsy, this level of accuracy could be transformative. Researchers in Germany are also exploring whether these devices can detect neurological diseases earlier than ever before. This is especially important in Alzheimer's disease. Across Europe, aging populations are creating enormous pressure on healthcare systems, and Germany is no exception. Neurodegenerative diseases are becoming one of the country's largest challenges. And because Alzheimer's disease gradually develops over many years, researchers are racing to identify biological warning signs before major cognitive decline happens. At the German Center for Neurodegenerative Diseases headquartered in Bonn, scientists are trying to find the earliest detectable signs in the brain. Instead of diagnosing Alzheimer's when memory loss becomes severe, future neurologists may be able to detect the disease years earlier, potentially preventing irreversible damage. The goal is ambitious, and AI is slowly becoming central to this process. Artificial intelligence has rapidly entered imaging worldwide, but Germany is quickly becoming one of Europe's centers for AI-assisted radiology. Modern MRI scanners now generate enormous amounts of data. A single brain scan can contain hundreds or even thousands of images. Reviewing them requires time, concentration, and specialized expertise. AI systems are now being trained to assist neurologists by rapidly scanning for abnormalities. At hospitals connected to institutions like Charité and the Technical University of Munich, researchers are developing machine learning algorithms that can detect the following: strokes, tumors, brain atrophy, and vascular abnormalities. Some algorithms can identify potential stroke patterns in seconds. The speed matters enormously. Every minute of interrupted blood flow can destroy millions of neurons. Rapid diagnosis directly affects survival and long-term disability. AI-assisted imaging may help emergency teams move faster, and Germany's hospital infrastructure makes it an effective testing ground for these methods. The country operates one of the largest healthcare systems in Europe. It has advanced neurological research networks distributed across these major cities. But brain imaging in Germany is no longer limited to structure alone. Researchers increasingly want to understand function, not just what the brain looks like, but how it operates in real time. This has led to major advances in functional MRI, also referred to as fMRI. Unlike conventional MRI, which primarily shows anatomy, fMRI tracks changes in blood oxygenation levels, primarily associated with neural activity. This allows doctors to figure out which regions of the brain became active during certain processes like emotion, language, movement, decision-making, among others. German neuroscientists have become highly influential in this field. At the Max Planck Society and universities across Germany, researchers are using functional imaging to investigate consciousness, psychiatric disorders, learning, and many other things. Some teams are even investigating how entire neural networks connect in the brain. This type of mapping is becoming increasingly important in neurosurgery. Before operating near critical brain regions, surgeons must first figure out where sensory, language, and movement regions in the brain are located. Functional imaging can help create highly detailed neural maps specific to each patient. In certain hospitals, advanced imaging is now directly integrated into the process of planning. The result is greater precision and potentially safer surgery. Germany is also exploring a new frontier of neurological imaging, hybrid systems. Traditionally, MRI and PET scans have been separate technologies. MRI provides anatomical detail, and PET imaging reveals metabolic or molecular activity. But newer hybrid systems combine both into a single platform. This allows neurologists to simultaneously study structure and function. For diseases like dementia, cancer, or epilepsy, the combination can be very powerful. Again, German engineering companies have played a major role in this technology. Meanwhile, entirely new forms of neurological imaging are continuing to emerge. One of the most closely watched fields is focused ultrasound. MRI guidance in this procedure allows researchers to watch the brain with great precision. In several German hospitals, researchers are using MRI-guided focused ultrasound as a treatment for several disorders, including Parkinson's and epilepsy. If you're interested in learning more about focused ultrasound surgery, you can watch another video which we made earlier. Germany is also becoming increasingly important in connectomics, the study of large-scale brain activity. At advanced neuroscience centers, researchers are trying to figure out how billions of neural connections interact with each other. This requires extraordinary computational power. Some projects combine MRI, EEG, PET imaging, and machine learning simultaneously. Others are trying to build models capable of predicting diseases before major symptoms happen. The line between data science and neuroscience is rapidly disappearing. And this shift is rapidly attracting enormous investment. German biotechnology and medical technology centers are rapidly moving towards neurological diagnostics. Companies traditionally focused on imaging hardware are now focused on software, AI, and others. The future brain scanner may not simply produce images. It may actively assist diagnosis. It can compare scans with millions of prior cases. It may detect abnormalities invisible to the human eye. And in some cases, it may even predict diseases years in advance. Advanced imaging systems are increasingly becoming expensive. Ultra-high-field MRI scanners may now require specialized facilities, highly trained staff, and complex cooling systems. AI systems also raise difficult questions. How should patients' data be protected? Can machine learning systems still be reliable across multiple populations and different hospitals? Germany has become one of the key countries debating these issues, and neurologists understand that imaging alone cannot help solve every problem. The human brain remains extraordinarily complex. Even the most advanced imaging systems cannot fully explain consciousness, memory, or psychiatric illnesses, but the progress is undeniable. In just over 1 century, Germany helped move neurology from indirect observation to real-time visualization of the living brain. Germany has repeatedly helped neurologists redefine what they can see, and perhaps more importantly, what they can understand. The next decade may even bring about more dramatic changes. Imaging systems may be able to map the brain at resolutions that were once thought of as impossible. Across laboratories in Berlin, Munich, and other cities, that future is already beginning to take shape, and Germany intends to remain at the center of that effort.